So we're going to walk through a case study that illustrates the differences between reduce when used with a sequential stream and reduce when used with a parallel stream. But first, we're going to take a look at how I used ChatGPT in order to refactor this code. So let's start by taking a look at the original code. So this is the code I had as of yesterday when I changed it. And if you look at this code, you can see all the methods here all are written in the same way. They all tangle together the benchmarking logic where we start a timer, then we do some operations that we want to time, and then we stop the timer, and then we print out the results. And if you look at all the code here, all the methods all use that same tangled approach. So when I looked at this code, I was like, gosh, this is really kind of messy because we're overly coupling the timing logic with the business logic, the logic we're timing. Wouldn't it be nice if we could find a way to refactor this code so that the logic of timing is moved out and we can make something reusable, and that will simplify our solution here? So, of course, my immediate inclination was to see if ChatGPT could help us here. So what I did is I said to ChatGPT, please take a piece of this code, this is the code we just looked at, and refactor it so all the timer-related stuff, and you notice I gave the timer-related pieces, are put into a separate class called BlockTimer that implements the Java AutoClosable interface, has a constructor that stores the start time in a field, a close method, which is what you get when you implement AutoClosable, that calculates the elapsed time, and an accessor method that returns the elapsed time. So you'll see I gave it a fairly specific set of things I wanted it to do, and then I gave it the code, and you'll notice here's the code that is the timer code, there's code that's the timer code. And what it says is I'm going to refactor this code into a separate class called BlockTimer. And lo and behold, it did a great job. So it made a BlockTimer class that implements AutoClosable. It has two fields, start time and elapsed time. Constructor records the start time. The close method is going to compute the elapsed time by taking the current time, subtracting the start time, and dividing by 1,000,000 to get into milliseconds. And then we have an accessor method called getElapsedTime that returns that. Great. So far, so good. And then it rewrites the code to kind of show how that works. So the next thing I said is, please generate another Java class called RunTimer that defines a static Java method called timeRun that takes a runnable as a parameter and uses a local instance of the BlockTimer class in conjunction with the Java try-with-resources block to record the amount of time taken to run the runnable and then return the elapsed time as the return value of the timeRun method. So that's just a nice English level specification of what I wanted. And ChatGPT says, sure, I'd be happy to do that. So it generates this RunTimer class with a timeRun method. And you can see it has a runnable parameter. It knew that it wanted to return a long. I didn't have to tell it that. And then it does something that's almost right, but not quite right. It makes an instance of BlockTimer in the try-with-resources block. Try-with-resources is a Java feature designed primarily for exception handling, but we can use it here too, where you create an instance here, or you pass it something that is AutoClosable, like a BlockTimer. And then when the close curly brace of the block is exited, the close method will automatically be called. And so what we do is we create the BlockTimer, it calls runnable run, that's correct, and then it returns timer getElapsedTime. The problem here is that the close method hasn't been called at this point. So as a result, it's not going to actually give you the elapsed time. And so I point that out to ChatGPT. I said, your solution doesn't actually work since the elapsed time is returned within the try-with-resources block, i.e. before the close method is called. Please regenerate time run so the BlockTimer is allocated as a local variable before the try-with-resources block has called the run method, and the elapsed time is returned after the try-with-resources block is exited. So this is a good example of prompt refinement. I knew enough to know this was incorrect. I described to ChatGPT what I wanted it to do. I could have just edited the code, but I wanted to see if it would do it right. And it says, of course, you're correct, because I was correct. And it regenerates the code, and now it has exactly what I want. It allocates the BlockTimer before the try-with-resources block, then goes ahead and does this and just ignores the result. I don't care about that. And it'll go ahead and call the close method after run is run, and therefore when we say timer getElapsedTime, it'll go ahead and return the right value. So then what I did is I said, please take this method, this is one of the methods from my code, and refactor it so the timing logic is decoupled from the rest of the method implementation. And so I gave it the method, which, as you can see, is still tangled. The logic for timing is still tangled with the business logic. And it basically took the code I gave it and then rewrote it exactly the way I want it to be rewritten without me having to rewrite it. And what it does is it makes a runnable. And you can see the runnable does the business logic. We call it operation. So all the business logic is in the runnable. And then down here, we say RunTimer, time run, pass in the runnable operation. That'll go off and run and record the time it took to do that. And then we store this in the elapsed time. And that gives us back the time to collect the strings took, and then we say the elapsed time in milliseconds. So really, really nice example demonstrating how you can use ChatGPT in order to refactor the code. And again, it also, I think, shows a nice example of prompt engineering. You don't get it right the first time. You don't throw up your hands and say, large language models don't work. You simply ask it nicely with a little bit better context to do the right thing, and boom, it generates the code, and you can then use it to automatically refactor the code. So a big win, much less effort and complexity involved.